This is lecture CAM 5 of the CAM 810S course. The topic of this lecture is assembly automation. There are two categories of automatic assembly: fixed or hard automation, and programmable or flexible automation. Let's start with fixed automatic assembly. Fixed automatic assembly is employed when a large number of products has to be assembled. We call this mass production. Parts are automatically fed, orientated, picked, placed or positioned, fixed in place, snapped in, tightened, and assembled. Parts may also be riveted, spot welded, or glued, among others. In fixed automatic assembly lines, there is very limited or no flexibility. That means that a change over to another product is hardly possible. The centerpiece of this assembly device is a so-called rotary index table. You have seen a similar setup in the YouTube video which you have seen previously. Small components are usually fed by a vibratory ball feeder. The vibration causes the parts to climb slowly along the helical ramps to the top of the feeder. At the end of the feeder, the parts are orientated in a particular direction, here to the right, with the head on top. This diagram shows how parts, here screws, are orientated. The screws move counterclockwise, that means from the right to the left. Screws which are not lying on their sides are rejected by a wiper blade, and they fall down into the ball again. The pressure brake rejects screws which are not in single file. Those screws also fall into the ball again. At the slot at the end of the ball, the screws are orientated so that the head is on top. From there, they continue to the next station. Components are picked and placed by two-axis pneumatic pick and place units. These are very fast devices. This diagram shows a feeding device to the left. The pick and place unit places the components to the rotary index table. Two components may be fixed together by a pneumatic press. Both pick and place, as well as fixing units, are equipped with pneumatic cylinders of different designs. All devices are arranged around the rotary index table. Fixed assembly automats are controlled by PLCs, programmable logic controllers. PLCs receive input signals on the top and send output signals below to all components of the assembly automat, thus controlling the process. As the name suggests, PLCs work with logic functions such as NOT, AND, OR, and combinations of these. Programmable or flexible assembly automation uses mostly programmable robots which handle the parts. This allows a high degree of flexibility because a robot can be reprogrammed to cope with different assemblies, different components, different locations, and different assembly sequences, and this in a relatively short time. This is an example of a flexible assembly automation cell. Car doors are assembled by a vertical articulated robot arm. The doors move along a suspension track from the left to the right. Parts or components placed on pallets move on an automatic conveyor below the suspension track. Glass panes for the doors are supplied on another conveyor on the right side, which is fed by an automatic guided vehicle. Assembled doors move to the right, and the next door arrives at the assembly station. For assembly of another type of door, the robot can be reprogrammed in a relatively short time. This is a car assembly plant. While the car bodies move continuously on a conveyor, a large number of robots assemble the car. This is the end of the 5th CAM 810 lecture. There is no exercise today. Please continue with CAM 6. Thank you.